Good afternoon, everyone. My name is Tuğçe Bashar. I'm an assistant professor at the Department of Civil and Environmental Engineering at the University of Illinois Urbana-Champaign campus. It is my pleasure today to share with you our research efforts going on, especially on geothermal systems. It is going to be today's topic. So I'm just going to share my screen now and to get this thing started. All right, so today's talk is going to focus on repurposing abandoned oil and gas wells for geothermal application to promote geothermal applications in low sediment, low temperature sedimentary basins such as in Illinois. So of course, this is a teamwork. I didn't do research by myself, so that's why I like to acknowledge my especially PhD student, Josie Angelo, who has been with me about 2 years now. And I also would like to acknowledge very talented and very smart and experts in their field from our industry partners and also Illinois State Geological Survey. So the motivation here is, of course, tapping into the geothermal energy. Well, as you well know, geothermal energy provides an uninterruptible source of energy, and we have to take advantage of this. It's different than wind and solar because it doesn't really depend on intermittent changes in the ambient conditions. And also it covers a very wide range of applications depending on the extracted temperature or production temperatures from a geothermal system. The figure on your right is actually taken from a report published by Department of Energy in 2019. It's an excellent study. It's an excellent report. I highly recommend that you go ahead, if you haven't heard of it, go ahead and read it. It's a little bit long, but trust me, it's worth it. And it also talks about the action items or the vision and mission of the Geothermal Technologies Office of Department of Energy. So one thing to mention, this project that I'm talking about, this concept I'm introducing, repurposing abandoned oil and gas well, is funded by Department of Energy back in 2020. And it consists of 2 phases. We finished phase 1, and now we are in preparation for phase 2. I'll talk a little bit more about it in a bit, but if you do have any questions about the project, so you can always reach out to us. So the figure on your right is the really good summary of different geothermal applications depending on the temperature, because temperature is the most important design parameter for our geothermal systems. As you can see here, the cut is really around 120 degrees Celsius between even made now 95 degrees Celsius between electricity production and space heating and cooling purposes. So there are, of course, challenges in geothermal energy, geothermal system development because they are site-specific and they depend heavily on subsurface temperatures and availability of groundwater, because for a geothermal system to operate, we really need water. And long construction times because of the deep drilling processes, and they may be really expensive if you want to drill really deep, maybe up to 5 kilometers. It's not impossible, but of course, as you go deeper, the pressure increases and temperature. So to get the desired temperature, sometimes you have to deal with really high overburden pressures in your reservoir. And of course, deep drilling costs us a lot of money, unfortunately. So there are many wells in the United States. So these wells do not include, just to take a note, that do not include geothermal wells. So these are documented and estimated undocumented oil and gas wells in the states registered in 2020. So you see that undocumented wells consists of a larger portion of the total wells in the United States. And approximately, there are various numbers on the predicted and estimated number of especially abandoned wells. And this number is taken from EPA, Environmental Protection Agency, and it's about 2.3 million, which is a really, really high number. So these abandoned wells, there are a lot of problems with these wells, right? And so a well, to decommission a well, so the decommissioning is one of the most important, actually, step in the well abandonment. And plugging and restoration cost per well for the states registered back in 2020 is given here. You can see that plugging costs can be up to $90,000, which is a lot, especially in states like Utah, because the wells are deep there, and the subsurface consists of rock mainly. And but if we just focus on Illinois, you see that at average plugging cost is around $50K, which is still a significant amount for one well actually to plug it. So if we do not properly plug the wells during the abandonment processes, they may cause very different problems. One of those problems include environmental risks and health hazards. So as you see in this animation, so this is our wellbore, and sometimes there are leakage pathways for methane and oil. So they may just leak to the different formations in the subsurface, especially in the aquifer, methane and oil. So this can cause serious environmental risks and health hazards. And there's also leakage of liquids like methane and oil again, but especially methane in this case. These are harmful gases into the emissions into the atmosphere. It actually accelerates the carbon emissions and thus the impact of climate change. And these wells are also economic burdens to state economies. Another thing to mention actually here is that especially in the state of Illinois, there are a lot of lawsuits going on right now because of the methane contamination of the groundwater, drinking water. So you're just at home and there are a lot of reported cases where residents had serious headaches and blurry vision and such. So, and this is a result of a methane leakage into the drinking water aquifer, actually, so which is a really big problem. So leakage into the atmosphere, methane is more harmful than CO2. And when you think about, you may think to yourself, okay, so we are dealing with oil, right? So oil is always accompanied by methane in the subsurface, just so you know. So it doesn't matter if you have an oil well or a gas well. If your well is not plugged and abandoned properly according to the procedures, it potentially leaks methane. And so methane is more harmful than carbon dioxide. And as you can see here, methane emissions here are reported for different couple of states and overall in the US and Canada, which are really, really high numbers. And you see this in this red box, the methane emissions into the atmosphere from unplugged or improperly plugged wells. So also, let's talk about the groundwater problems. So records of shallow groundwater contamination by methane was reported, we said, and records of alterations to the local hydrology and water quality from methane are also recorded. As you can see, these pictures are the surface alterations from abandoned oil and gas wells that was reported in 2021. You see this methane escape from the subsurface. So it causes different problems, but especially what we really care here about is the contamination of groundwater. And of course, not to mention about the explosions, right? So there are many cases reported, unfortunately, especially in the Gulf of Mexico, that was caused by gas accumulations and differential pressure buildup in the plugged wells. And so they can lead to explosions on the surface, and such as it happened in California in 1972. There was an explosion during tunnel excavation, and there were 17 fatalities. And store explosion in Los Angeles in 85, 23 injuries. An explosion at the construction site in Colorado in 2007. So any fatality or even one injury, it's significant. So it shouldn't really happen. So we focused on abandoned oil and gas wells so far. But what if a well is properly abandoned, right, according to the procedures and according to the procedures that are developed and mandated by the states? But sometimes, unfortunately, even though we follow the procedures, depending on the site-specific conditions, so these wells may pose significant risks for explosion, methane leakage, and also groundwater contamination. So our purpose here with this project to rehabilitate actually and repurpose those, especially abandoned oil and gas wells, and to promote and enhance geothermal system development in low temperature basins such as Illinois. So there are different available technologies to actually utilize these abandoned oil and gas wells. So one of them is co-production. So this includes simultaneous production of hydrocarbon and geothermal energy. There are examples, I believe, in Canada right now. And so they're economically viable and mature oil wells, and the extension of the economic life of the field is possible, made this possible, and there are also environmental benefits. There are also full well conversions. This includes a full transformation of a hydrocarbon well into a geothermal well. So you may ask, what is the difference between hydrocarbon wells and geothermal wells? With geothermal wells, we're talking about really high temperatures because we would like to produce electricity mainly from these development, if it's possible at all. But here, for the geothermal development, there are a lot of advantages using those wells because it eliminates cost of plugging and decommissioning, and it eliminates exploration and drilling costs for geothermal operations, because for the oil and gas well drilling, we already do those explorations, and we usually have the record of those exploration, and it also has a lot of environmental benefits. So for the well conversion, there are two configurations available. One of them is open loop system, and the other one is a closed loop system. So we are looking at the open loop system here. We have a production well, an injection well. This is where we inject cold fluid from a power plant, which includes a heat exchanger. So this heat exchanger can be really big and powerful in any geothermal power plant. This is where we inject cold water, and then using the subsurface temperature geothermal gradient, and to get the hot water out that goes to the power plant for electricity production. And for this configuration, a minimum of 2 wells are needed. And this system generates high energy output, but they are site specific. So these are limited areas where 2 abandoned wells are close to each other. So there's a closed loop system. This is where we have only one single well. And this is applicable when well is no longer producing hydrocarbon, which is mature. But these have low heat extraction performance, low pumping work, which is also economically viable. And So this is no requirement for water management system, because this is a really closed loop. This is, you're not letting the water out of your system. And there are different types of heat exchanger that are used, U-tube and double pipe heat exchangers. So for a full well conversion, which is the focus of the study, there are some key information needed to define the well conversion. So we need to determine the integrity of cement and casing of the well, which are really important, because integrity of cement is very, very important, because most of the failures and leakage actually happens because of the instabilities in the cement. Borehole sealing from surrounding formations and aquifers, and aging assessment of the well bore. So there are existing projects, but they mainly right now focus on co-production. Full well conversion studies are also available or under development. And so this is what we are actually working on right now, for a full well conversion of a matured gas well, especially in southern Illinois, which is very abundant. And some examples from the oil fields are from USA and China. So you are looking at the reservoir temperatures, 110 degrees Celsius, 120, 85. The depths for these different fields are not, all of them are reported. Geothermal gradients, especially for the Hubei oil field in China, it's around 35, which is a really high geothermal gradient and good. So these projects are increasing as we know a little bit more about how to perform full well conversion, and our research is actually making this possible. And there's another significant project in Europe, which is called MEET. And so this project seeks to utilize low temperature resources from oil and gas operations to generate electricity, which is really close to our work here. And the work that we have done actually was introduced by my PhD student earlier in this workshop. So if you're curious about how we actually did all those work especially in the field, in addition to the numerical analysis, I highly recommend that you go to her recording and then find out more information. So to conclude, I don't have enough time to explain everything, but to conclude, so there are the factors affecting economic and technical feasibility of a co-production project are the bottom hole temperatures, flow rate, and water cut ratio. And for a full conversion project, bottom hole temperature, flow rate, and petrophysical parameters. Stratigraphy, those thermal and hydraulic properties are very important and significant. And there's also this research side of it, or the application, but there is also policies and law involved in the full conversion. So these policies that regulate the conversion processes are necessary. Currently, there are none, unfortunately, but we are really working hard. We are really trying to engage with the DNR of the state of Illinois to actually implement some policies and laws for a full conversion. And evaluation on a case-by-case project is very important for an accurate characterization of the subsurface processes and to assess the operational, technical, and economic feasibility of the project. Well, thank you so much for your attention. I do hope that you enjoy the presentation. This was an overview, just so you know. If you're curious about the details of the project, you can reach out to us at these emails, and we will be happy to chat more. Thank you.